Hello and welcome to the 5,000 people following us for this press conference to present Climate Change 2021, the Physical Science Basis, which is the Working Group 1 contribution to the IPCC's 6th Assessment Report. Today we have with us the heads of the IPCC's two parent organizations, Inger Andersen, Executive Director of the United Nations Environment Programme, UNEP, and Petteri Talas, Secretary General of the WMO, World Meteorological Organization. We also have the Chair of the IPCC, Wei-Sung Lee, the two co-chairs of Working Group 1, Valerie Masson-Delmotte and Panmal Jai, and the Secretary of the IPCC, Abdallah Moqsit. We also have several members of the Working Group 1 Bureau who are available for questions, and I'll introduce them later. We're going to start with brief opening remarks from our panelists and then a presentation of the new report by the co-chairs, and then there'll be plenty of time for questions and answers. This press conference can be followed by the public. Registered media can ask questions. If you do, please include your name and your outlet. I'd now invite Abdallah to introduce the press conference. Abdallah?
Thank you, Jonathan. I am pleased and proud to welcome you all to this virtual press conference. It follows something unique and unprecedented for the IPCC and for many other international organizations. We have just completed a virtual approval session. Virtual, session, but virtual approval session, it is the first one in the history. I want to highlight this. It is the first virtual approval session. Not only was it the first in IPCC history, it was also one of the few approval sessions that did not run into extra time. And probably with the largest participation of delegates. When we first realized over a year ago that the pandemic might force us to hold a virtual session, many said it was impossible. It was impossible. People raised concern about connectivity problems as well as inclusivity as well as transparency. In the IPCC Secretariat, we worked intensively with our Bureau and with the Working Group 1 Bureau in an exhaustive consultation with our member government to find a format that would be consistent with the values and principles of the IPCC. IPCC should have a neutral and policy neutral outcome. And we succeeded. I am proud to say that we succeeded. We succeeded. Over 2 weeks, we worked calmly and efficiently without a technical hitch. No, zero technical hitch. This is something to flag. Whatever time was scheduled, a session was unsocial. Hours for someone, we had delegates and authors join in from UTC plus 13 hours, like in Samoa, to UTC minus 7 hours in the North American West Coast. Our participants clocked out 186 hours on virtual platform during these 2 weeks. And they were working an average of 12.6 hours a day. I should not reveal that to you that what it said in closed IPCC meeting. But I can tell you that many delegates in their closing statements said that this was the most successful IPCC approval session they could remember. Just to have flagged that in this comparison, they include even the personal the plenary in person. That means this virtual one was the best one compared to even other physical one. We had a record of attendance of 739 participants. And this is really a record. We never have in-person plenary that number of participants. And as you are about to hear, the result was one of the strongest and most significant report in the IPCC has produced. And this report for Working Group 1 is coming to fill the basket, the package of the 6th cycle, for which we are producing 8 reports, making this 6th cycle the most intense, the most rich in the IPCC history. Once again, it is a record. I would like to take this opportunity to thank the Working Group 1 co-chair, Valerie and Pan Mao. I want also to thank Bureau members, the 234 authors, and also the technical support unit team, the Working Group 1 as the others as well. And also, I want to thank very warmly my small secretariat, which is like a beehive, working non-stop. We have no time zone for IPCC Secretariat. I want to like to thank Harmony, our parent organization. And also, yes, I want to thank our chair for his leadership through all this process. In this 6th cycle, we are making a story. So I want to thank all the one who contributed in background to this process. So with this word, I want to turn to Jonathan. Jonathan, you have the floor.
Thank you, Abdallah. And we now have over 7,000 people following us on this press conference. And I'll invite Inga to make some opening remarks.
Thank you very much. And let me just echo what Abdallah just said. A warm and sincere thanks to everyone who's been involved in this, to the IPCC, to the authors, and to everyone who has been involved in this latest climate alarm. Your work, based on science, is particularly appreciated given the disruption of COVID-19. You've been telling us for over 3 decades of the dangers of allowing the planet to warm. The world listened, but didn't hear. The world listened, but it did not act strongly enough. And as a result, climate change is a problem that is here now. Nobody's safe, and it's getting worse faster. We must treat climate change as an immediate threat, just as we must treat the connected crisis of nature and biodiversity loss and pollution and waste as immediate threats. As recently noted in the IPCC and the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, IPBES, the twin to IPCC, if you like, under the CBD Convention, we understand that climate change exacerbates already grave risks to biodiversity and natural managed habitats. Ecosystem degradation damages nature's ability to reduce the force of climate change. And as the IPCC Working Group 1 report reminds us, reducing greenhouse gases will not only slow climate change, but will improve air quality. It's all connected. It's time to get serious because every ton of CO2 emission adds to global warming. As the UNFCCC noted last week, 110 countries, just 110 out of 191 parties to the convention have submitted new or updated NDCs ahead of the next climate COP. Governments need to make their net zero plan an integral part of their Paris commitments. They must finance and support developing countries to adapt to climate change, as promised under the Paris Agreement. They must decarbonize faster. They must restore natural systems that draw down carbon, cut out methane and other greenhouse gases faster, get behind the Kigali Amendment to the Montreal Protocol to cut the climate impact of the cooling industry. And every business, every investor, and every citizen needs to play their part. We can't undo the mistakes of the past, but this generation of political and business leaders, this generation of conscious citizens can make things right. This generation can make the systemic changes that will stop the planet warming, help everyone adapt to the new conditions, and create a world of peace, prosperity, and equity. Climate change is here now, but we are also here now. And if we don't act, who will? Thank you.
Thank you very much, Inga. And now I'd invite Petteri to take the floor.
Thank you, Jonathan, and thanks for inviting me for this opening of this important session. WMO organized the first World Climate Conference already in 1979 to establish IPCC. The risk of climate change was caused by growing consumption of oil, coal, and natural gas was recognized by the meteorological community. IPCC has been working under WMO and UNEP since then, and WMO has been proud to host the IPCC Secretariat. Now we are publishing the physical science part of the sixth assessment report, which is summarizing the results published in peer-reviewed scientific literature during the last 8 years. I would like to thank hundreds of authors and reviewers of this massive report, and especially I would like to thank Valerie Masson-Delmotte and Panma Zai, who have been leading the work and have devoted several years of their career for IPCC. You will soon hear the main findings of this report. The key messages are still the same as in the first IPCC report, which was published already in 1988. Namely, climate change is already detected by using several measured physical parameters. Secondly, the human-induced emissions of greenhouse gases, especially carbon dioxide, will pose a threat for human well-being and for the biosphere. And thirdly, reduction of the emissions of greenhouse gases would be needed and recommended to minimize the risks of future climate change. The report published today echoes the same messages with much higher urgency. Climate change is already more visible, and the emissions have grown more rapidly than we ever expected in 1979. I had a chance to follow this also personally as a scientist since the 80s, and professor and also chair of the National IPCC Committee and National Delegate. Natural variability has always been causing weather extremes and will do so also in the future. We just closed the Tokyo Olympic Games yesterday. By using sports terms, one could say that the atmosphere has been exposed to doping, which means that we have begun observing climate extremes more often than before. That means record-breaking temperatures, drought, forest fires observed also this year and also during these days in Greece, in California, for example. We have also more water vapor in the atmosphere, which has led to severe flooding problems as observed in Central Europe and China recently with several casualties, unfortunately. The warming of the oceans has affected the frequency and area of existence of the most intense tropical storms, hurricanes, typhoons, and cyclones. Have we lost the hope? No one, yes. According to this report, we are still having a chance to stop the negative climate trend during the mid of this century by especially limiting the use of fossil fuels and by stopping deforestation. Some changes will continue for centuries or even thousands of years, like sea level rise, melting of glaciers, and shrinking of Arctic sea ice and snow cover. The report underlines the urgency to enhance the ambition level of climate mitigation. We are not yet heading towards Paris limits 1.5 to 2 degrees warming by the end of this century. At UN, our aim is to reach 1.5 degree warming level, which would be best for the welfare of mankind and biosphere. Now we are heading towards 2 to 3 degrees warming instead. We have received encouraging pledges by several countries, which would mean about 2.1 degree warming if materialized as promised. This is not enough to avoid several harmful impacts like loss of food production capacity, water shortages, extreme heat, forest fires, continued sea level rise, potential of refugee crisis, and the negative impacts on world economy and biosphere. Besides climate mitigation, it is essential to pay attention to climate adaptation, since the negative trend in climate will continue for decades and in some cases for thousands of years. One powerful way to adapt to is to invest in early warning climate and water services. Only half of the 193 members of WMO have such services in place, which means more human and economic losses. We have also severe gaps in weather and hydrological observing networks, especially in Africa, some parts of Latin America, and in the Pacific and Caribbean island states, which has a major negative impact on the accuracy of weather forecasts in those areas, but also worldwide. The message of the IPCC report is crystal clear. We have to raise the ambition level of mitigation. The forthcoming COP26 meeting in Glasgow this November will be a critical milestone to combat climate change. By using sports terms again, we need the sport already during this decade, not just before the finish, as we do at the running competitions. Thank you.
Thank you, Petteri. And I now invite Hui-Sung to introduce the report.
Thank you, Jonathan. Firstly, I would like to recall that today is the International Day of the world's indigenous peoples. IPCC assessments draws on enormously and also to respect indigenous knowledge all over the world. We recognize that traditional agricultural practices can be resilient to climate and non-climate stressors, and indigenous knowledge systems and practices allow local people to adapt to many climatic changes. I would also like to inform you that this report is dedicated to the memory of Sir John Houghton, one of the key figures in the creation of the IPCC in 1988, who served as chair and co-chair of Working Group 1 and who died in April last year. And the Interactive Atlas, one of the innovative aspects of this report, is dedicated to the memory of Gemma Teresa Narisma, one of its coordinating lead authors, who sadly passed away in March this year. The report that we are presenting today is the result of an unprecedented effort by the IPCC community. On top of the intense efforts required for any IPCC report, we have faced the challenge of completing the assessment in a pandemic, which obliged us to shoulder not only extra work, but develop new ways of working to get the job done. This was an unprecedented effort, but we finished on time with greater participation than usual and have delivered strong, clear scientific assessment of climate change. Many thanks to the authors who took on this responsibility to deliver the report, and to the Working Group 1 Bureau, Technical Support Unit, and the IPCC Secretariat who made this possible. Let me also thank the government of France and China for their generous support of the TSU and of Spain for its support of the interactive atlas. And thanks to our member governments who provided us with necessary guidance so that we could hold a virtual approval session and then participated in the meeting in a spirit of cooperation and collegiality to approve the report. IPCC reports are for policymakers, and it is particularly rewarding to see the wealth of policy relevant information in this report. For instance, the regional focus and regional data that will support policymakers in their decisions. This focus on regional information with new chapters and the interactive atlas is one of the many innovative aspects of the report. Others include dedicated chapters on human influence on climate and on the interaction of a changing climate with extreme weather events. This report will serve as a timely new evidence base for negotiators at the COP26 negotiations starting in less than 3 months. It will be a valuable toolbox for negotiators as they consider the level of ambition at COP26 and together with the rest of the sixth assessment report as they prepare for the global stocktake. This report, Climate Change 2021, the physical science basis, expands our knowledge of attribution of climate change, including the human contribution to extreme weather events. And it provides us with an improved understanding of climate change, including warming, past, present, and future. First, it tells us that it is indisputable that human activities are causing climate change and making extreme weather events more frequent and severe. Second, it shows that climate change is affecting every region on our planet. And lastly, it explains that strong, rapid, sustained reductions in carbon dioxide and other greenhouse gas emissions would be required to limit global warming. My colleagues Valerie and Panmao will now give you a more detailed account. I hand back to Jonathan.
Thank you very much, Hui-Sung. And I now invite Valerie and Panmao to present the new report. Please bear with us for a few seconds while we switch the presentation.
Thank you, Jonathan. Before we get on to presenting the findings of the IPCC sixth assessment report on the physical science basis of climate change, I'm proud to unveil the artwork that is featured on the cover page of the report. An artist created this piece of visual art on this front cover, having been inspired by a scientific figure in our summary for policymakers. This global view highlights one of the most important messages from this report, that climate change is already affecting every region on our planet, and every fraction of additional warming will increasingly affect every region in multiple ways.
The IPCC does not conduct new research itself. Instead, the hundreds of scientists who worked on this report come together to assess the current state of knowledge of the science of climate change. They reviewed over 14,000 studies, massive amounts of data. In this assessment, we welcomed the new authors, 2/3 of whom had never been involved as the authors of previous IPCC reports. Our team was made up of scientists from 66 countries around the world. In the review process, 3 phases of review by governments and experts, we took on board over 78,000 comments from experts and the governments. All review comments are addressed by the authors. And because of the pandemic, these meetings moved online, and we had to invent an entirely new way of working, which ended up in this unprecedented online approval process over the last 2 weeks. People said we couldn't do it, but we did.
Since the last assessment report in 2013, there have been important advances in climate science worldwide. During these years, climate scientists filled in gaps in observations of past climate. They improved climate models and developed new ways to combine many types of evidence. As a result, today, we have the clearest picture of how the Earth's climate functions and how human activities affect it. We know better than ever how the climate has changed in the past, how it is changing now, and how it will change in the future.
Of course, we have known for decades that the world is warming, but the recent changes we have seen in the climate are now widespread, rapid, and intensifying. Some of the changes we see today are unprecedented in thousands of years or never seen before. The recent rate of warming is unprecedented in at least 2,000 years. To measure how the climate is changing, we looked at a key indicator, the average temperature of the Earth's surface over a period of at least a decade compared to the average in the late 1800s. If we took at the last 10 years, the average surface temperature was 1.1 degrees Celsius warmer. In fact, each of the last 4 decades has successfully been the warmest since the late 1800s. Temperature is not only aspect that is being altered. Levels of heat-trapping gases in the atmosphere continue to increase fast. Current CO2 concentrations are the highest they've been for at least 2 million years. Over the past 100 years, sea level has risen at faster rates than it ever did in at least 3,000 years. Some Arctic sea ice area is at its lowest in at least 1,000 years. And the retreat of glaciers on global scale since 1950 is unprecedented in at least 2,000 years. The warming we have already experienced has far-reaching consequences. Climate change is contributing to increase in extreme heat, heavy precipitation event, and the drought. Since 1950s, hot extremes, including heat waves over land and the marine heat wave, have become more frequent and more intense. Heavy precipitation events have become more frequent and more intense. And we see increasing drought in some regions. These consequences to heat, rainfall, and the drought touch our whole planet, not just people, but also plants and animals, both nature and agriculture. The growing season of plants has lengthened on average in large parts of the Northern Hemisphere. Fire weather, the combination of dry, hot, and windy conditions that is conducive to wildfire is becoming more frequent in many parts of the world. Multiple changes are taking place in ocean, which is warming, acidifying, and losing oxygen, affecting ocean life and the people who depend on it.
There will be further warming in the coming decades. What is clear from this report is that unless there are immediate, strong, rapid, and large-scale reductions in greenhouse gas emissions, limiting global warming to 1.5 degrees Celsius will be beyond reach. The report shows that in the next 20 years, global warming, the average temperature at the Earth's surface over a period of 20 years, is expected to reach or exceed 1.5 degrees Celsius above the late 1800s. However, if we rapidly reduce greenhouse gas emissions, if we can reach global net zero CO2 emissions around 2050, it is extremely likely that we can keep global warming well below 2 degrees. If we do this, it is more likely than not that temperature would gradually decline to below or around 1.5 degrees Celsius by the end of the century, with a temporary overshoot of no more than 0.1 degrees Celsius. But if global greenhouse gas emissions remain around today's levels in the coming decades, we would reach 2 degrees of global warming by the middle of this century. With every additional amount of global warming, we will see greater changes in the climate. Every additional half degree of warming will cause increases in the intensity and frequency of hot extremes, heavy precipitation and drought. At 2 degrees of global warming, heat extremes would more often reach critical tolerance thresholds for agriculture and human health. At a global scale, extreme daily rainfall events intensify by about 7% for each additional degree Celsius of global warming. As you see, future further changes depend on future human influence. Now, Panmau, let's go back to where we are today.
It is disputable that human activities It is indisputable that human activities have caused and are causing climate change. That what's new in this report is that we now have a much more advanced understanding of the connections between the emissions we release and the rise in global surface temperature and the change to weather and the climate we are seeing around the world. It is unequivocal that human influence has warmed the atmosphere, ocean, and the land. Almost all the observed warming from the late 1800s is human caused. In this report, we looked at all the atmosphere gases that affect the climate. We confirmed that human caused emissions of greenhouse gases are the main driver of global warming. And we can see clearly how much warming comes from carbon dioxide, methane, and other greenhouse gases. We can also assess the influence of pollution particles that called aerosols, which have an overall cooling effect. This cooling effect partly masks the warming from the greenhouse gases. We also looked at all the natural factors that can affect the climate. We take into account how natural climate variability modulates human-caused changes at the regional scales with little effect on global warming at the central scale. Another major advance in our understanding of human emissions is how our emissions lead to specific changes in the climate, including extreme weather and climate events. We know today that human influence is already making extreme weather and climate events, including heat waves, heavy precipitation, and the droughts, more frequent and more severe. Hot extremes, including heat waves, have become more frequent and more intense since 1950s. And some recent hot extremes, in the last decade would have been extremely unlikely without human influence on the climate system. Furthermore, we know that human influence has been the main driver of ocean warming since 1970s, and that human-caused CO2 emissions are the main driver of ocean acidification. Human influence in contributing to reduced oxygen levels in the ocean observed since the mid-20th century. Human influence is also the main driver of change we see in the frozen areas of the planet, the cryosphere, driving the global retreat of glaciers since the 1990s, the 40% decrease in Arctic sea ice since 1979, and the decrease in spring snow cover since the 1950s. It is very likely that human influence contributed to surface melt of Greenland ice sheet in last 20 years. These advances in our understanding of how human activities are affecting the climate mean that today we can better estimate the change we may experience, both gradual trends and extremes, resulting from different amounts of emissions, different levels of warming, and across different regions. Climate change is already affecting every region on Earth in multiple ways. But climate change manifests differently depending on where in the world you are. There are different combinations of changes in every part of the world. In this report, we added more new information that is useful on a regional scale. This is an area of climate science that has rapidly advanced in the last 10 years. To reflect this and provide more information helpful to inform decisions related to risk management and adaptation, around a third of our report is dedicated to regional climate information. As a part of our focus on regional climate information, we also introduce a new concept of climatic impact drivers to help translate physical changes in climate, heat, cold, rain, drought, snow, wind, coastal flooding, and more into what they mean for the society and the ecosystems. We are not only looking at gradual temperature increases, but also at the specific conditions where heat goes over thresholds known to lead to severe consequences for people, agriculture, and wildlife. Many of the changes we assessed are related to the global water cycle. The water cycle means how water moves through the atmosphere, land, ocean, and the cryosphere. With warmer temperatures, the atmosphere can hold more water, and we see more and faster evaporation and heavier precipitation. The monsoon rainfalls, which are also important to so many peoples, are changing in complex ways in response to the contrasting effects of both greenhouse gases and the pollution particles, which we call aerosols. With more global warming, the global water cycle will intensify. That means both heavy rainfall at the same time as we see intensifying drying seasons and droughts. With more global warming, average annual rainfall on land is expected to increase, but that rainfall is expected to become more variable within a season and from year to year. The interactive atlas launched today makes our global and regional climate information available to all. It includes observations of ongoing changes, the projections of future changes. And you can see the interactive atlas to make your own maps. You can use interactive atlas to make your own maps and analysis using the datasets we used in the report. You can use interactive atlas to find out what climate change means for where you live. Valerie, back to you.
Thank you, Pan Mao. Moreover, many of the changes set in motion by human-caused climate change are slow processes. These long-lasting changes, for most part, affect the planet's frozen regions, the cryosphere, and the ocean. Changes in ice sheets, deep ocean temperature, and acidification will continue for centuries to thousands of years, meaning that they are irreversible in our lifetime and will continue for generations to come. In this report, we show that over the course of this century, global ocean temperature is projected to rise 2 to 8 times as much as it has increased since the early 1970s. The melting of the Greenland and Antarctic ice sheets will continue for thousands of years. This means that sea level will keep rising. Coming back to today, the rate of sea level rise keeps increasing, and the rate of ice sheet loss has increased by a factor of 4 in the past 30 years. The good news is that these irreversible changes can be slowed down with rapid, strong, and sustained reductions in emissions. And other changes can be stopped if greenhouse gas emissions are deeply reduced. For example, retreating glaciers and Arctic sea ice will continue to decline for at least several decades. But these changes could be slowed and stopped if emissions are reduced. To limit global warming, strong, rapid, and sustained reductions in CO2, methane, and other greenhouse gases are necessary. We know that CO2, carbon dioxide, is the key greenhouse gas driving climate change. We know it comes, from the most part, from the burning of fossil fuels. This report reaffirms that there is a near linear relationship between the cumulative amount of emissions of CO2 in the atmosphere from human activities and the extent of observed and future warming. This is physics. This means that the only way to limit global warming is to reach net zero CO2 emissions at the global scale. Every additional ton of CO2 emissions adds to global warming. Our report gives more details on how reducing emissions will affect the climate. For instance, it quantifies just how much more CO2 we can release and still have a chance to limit warming close to 1.5 degrees Celsius or 2 degrees Celsius. We know that today, around half of our CO2 emissions are taken up and stored by plants, soils, and ocean. We assess how these processes change with future emissions. And we know now that if we release ever greater amounts of CO2, these natural carbon sinks would actually take up a smaller proportion of our future emissions. This report also shows that while CO2 is the dominant greenhouse gas related to human influence on climate, and reaching net zero CO2 is required to limit global warming, strong reductions in other greenhouse gas emissions are needed. Amongst these, methane reductions, together with strong air pollution controls, would benefit both the climate and improve air quality. Our planet is warming. and it is warming quickly, with increasing consequences everywhere. This report is clear that it is possible to limit future warming within a few decades. The climate we experience in the future depends on our decisions now. Thank you.
Thank you very much, Valerie and Panmal. We're now ready to take questions from registered media. We already have quite a few in, so I expect we'll be running the Q&A session until 11:30 Geneva, Paris time. A reminder that media should include their name and outlet with any questions they submit. Besides the panelists who have already spoken, we have several members of the Working Group 1 Bureau who are available to respond to questions too. They are Jan Fuglestvedt, Carolina Vera, Irfan Tariq, Fatima Driwesh, Edwin Aldrian, and Greg Flatto. So I'll go to the first question now, which is from Toshiya Kaba of the Tokyo Shimbun newspaper, who's asking about the effect of the coronavirus pandemic on climate change. Valerie, would you like to take that?
Yes, thank you for the question. So our report shows that due to the lockdown implemented in the pandemic context, there have been temporary reductions in emissions of CO2, a few percent at the global scale. But these temporary reductions were not sufficient to have a significant impact, and therefore the rise in atmospheric CO2 concentration in the atmosphere has continued. Moreover, there have been reductions in emissions of air pollutants, temporary reductions as well, leading to immediate improvements in air quality. These are the two aspects related to the pandemic that are assessed in this report.
Thank you, Valerie. And next question comes from Sung-Wook Park of JTBC, who says that many countries have committed to a carbon neutral net zero 2050. But as we know, greenhouse gases, especially carbon dioxide, last hundreds of years once emitted. Will it be possible to keep temperatures within 1.5 or 2 degrees in 2050 or this century as a whole? Again, Valerie, please.
Thank you, Jonathan. So in this report, the assessment is based on 5 scenarios and the assessed response of global temperature. This report shows that in all the assessed scenarios, global warming would reach or exceed 1.5 degrees Celsius in the coming 2 decades. However, if emissions are reduced rapidly, and if at the global scale, they reach net zero by around 2050, then temperature would be very close to 1.5 degrees Celsius by the mid of the century and would decline lower to that level by the end of the century. So this is what we provide. We provide an updated understanding of how the climate responds to emissions. And this is a critical information that is available to inform decision-making worldwide.
Thank you, Valerie. Petteri, do you want to come in on that? No. Okay, then the third question is from Andy Revkin of Revkin Bulletin, who says some climate campaigners and scholars, including at least one long-time IPCC author, criticize the panel process as erring on, quote, the side of least drama, unquote. Is that valid? Maybe, Valerie, you want to start on that, but I expect others might want to come in.
I would like to thank the authors of the report, the hundreds of scientists, for all their efforts to ensure that the report reflects the wealth of available climate information and provides a balanced assessment of where we are and where we could go. For that purpose, the report provides our best estimates, for instance, for the climate response. It also provides a complete description, including what is extremely important for risk management. It is the events that have a small chance of occurring but could lead to very large-scale impacts. And therefore, the report also provides information on very rare climate extreme events or multiple events occurring at the same time that are very important to consider. It also explores what could happen in the case where poorly understood processes leading to the Antarctic ice sheet collapse would start to occur. And therefore, the report also provides high-end estimates for what sea level rise could be in this type of situation. And this information was requested by decision makers because it's extremely important for those who manage critical infrastructure. And the report provides a wealth of information that can be useful and actionable for decision makers to take into account all the scale of risk, especially those taking decisions related to critical infrastructure.
Thank you, Valerie. Inge, please.
Simply to add that the drama is playing out on the front pages of the newspapers today in terms of climate impacts that we're seeing already. So this is a scientific report, and we've already heard from Dr. Masson-Delmonte and Dr. Zai. But I think as citizens and as businesses and as governments, we're well aware of the drama. And so the drama exists, we have seen it, and we heard about it in every news bulletin. And that's what we need to understand, that the expression of what the science says is exhibited before our very eyes. And of course, what this excellent report does is it projects these scenarios outward and tells us if we do not take action, what could be the potential outcomes, or if we do take action, what will be a very good outcome. So the power is in our hands at this point. Thank you.
Thank you. Petteri?
Yeah, so I have been following this process since '88, and of course these findings of this report, they are not comfortable. So and that's why it's important to pass these messages for decision makers and general public. And of course, we have the fact that sometimes media is speaking only those most negative things. And more recently, there have been attacks against IPCC saying that IPCC's reports are too mild. So in the past, we were having very much this kind of skeptical attacks against science and IPCC itself, but more recently, some people are saying that these reports are too mild. So and I think that's a little bit demonstrating that we are on the right track, and this is very much based on extremely solid science. It's not based on individual scientific papers, but it's a balanced view of the maturity of science, and I would like to encourage you to trust those results.
Thank you, Petteri. Carolina?
Thank you. I would like to take the opportunity to also point it out a different aspect that the reports allows the society, to move away from that perfect perception that we are shifting from a sane zone to one where we experience dramatic changes everywhere overnight. The report clearly shows that we are living the consequences already of climate change everywhere, but furthermore, that we will experience further and concurrent and multiple changes that increase with every additional bit of warming. We should be prepared for that. Thank you.
Thank you, Carolina. Okay, next question from John Cannon of Monga Bay. The authors say the ocean and land carbon sinks aren't likely to be as effective at slowing carbon dioxide accumulation. Is that just to do with the proportion of carbon they can pull out of the atmosphere, or might it be due to changes in oceans and tropical rainforests affecting how they take up carbon? Valerie?
Thank you. So in this report, we explore the response of the ocean and land carbon sinks to the effects of different scenarios of human greenhouse gas emissions, especially the role of CO2. And a major finding is that today the ocean and land sinks give us a huge service by storing around 56% of the 40 billion tons CO2 we emit in the atmosphere every year. And a novel finding is that their relative efficiency at absorbing a fraction of our emissions would reduce if we emit higher and higher amounts of CO2 in the atmosphere. The report also looks at how they would react if we stabilize and reduce, get to net zero or net negative CO2 emissions. So this is taken into account in the assessment, for instance, of the remaining carbon budgets related to stabilizing warming at specific levels.
Thank you. And a question from Holly Chick of the South China Morning Post. What role does China play in combating climate change as the world's largest greenhouse gas emitter? And yeah, that's the first question from her. Pan Mao, could you take that one, please?
Thank you, Jonathan. And since IPCC is assessing, not in a position to assess climate change or actions for individual member countries, and way more focus on global and regional perspective. And for Working Group 1, we also more focus on physical science. However, in this assessment report, we paid much attention on the regional information. As I already reported, about 1/3 of information is for the regional one. So for the region of China, that's part of East Asia. East Asia, we see a lot of extreme events happening. The heat wave have increased and are also project to continue in the future. And the daily precipitation extremes increased over the many parts of the region. And also we see intensifying and a strong influence of the tropical cyclones. And the drought has become more frequent and more severe in several parts of the area. And I think so a lot of regional information help us into this time to address the impacts. That's it. Thank you.
Thank you, Pan Mao. And Inga, please.
So, merely to add that the G20 countries bear a special responsibility. Together, they are nearly responsible for around 80% of all global emissions when we take out land-based sources, and accordingly, therefore, have a unique opportunity to really help in reducing CO2 and greenhouse gas emissions. This is based on UNEP's emissions gap report, which we issue every year around COP. And so simply to say that the G7 and the G20, and that includes in the latter, obviously China, but includes another 19 countries, bear a special responsibility. And we certainly urge them in their upcoming Heads of State Summit to live up to the facts that are on the table right now and to submit ambitious NDCs. Thank you.
Thank you, Inga. Okay, a question from Kiyoshi Ando of Nikkei. It seems impossible to limit the temperature rise to below or equal to 1.5 degrees unless we follow scenario SSP1 1.9. For many countries, that hurdle is too high, and this could make them just forget about the Paris Agreement. How could you avoid such risks? Valerie?
Thank you, Jonathan. What I would like to stress is the following. The report is very clear, the science is very clear that what drives further warming compared to today is future emissions. So this is really in our hands. And when you look at the low emission scenarios from the report and the very low emission scenario from the report, they share common characteristics. Rapid declines in the rate of greenhouse gas emissions at the global scale in this decade, in the coming decades, and reaching net zero for the lowest one in 2050 and for the low one in the 2070s. The second one, the low emission scenarios, leads to limiting warming well below 2 degrees Celsius. The first one leads to limiting warming very close to 1.5 degrees Celsius, within 0.1 degree. So this is what we provide as a precise, robust scientific information to inform decision making.
Thank you, Valerie. Okay, I have two questions which are similar, so I'll give them both and they can be answered together. One is from Kate Nicol-Williams of TV New Zealand. How much stronger is this report in the world's understanding of the impact of climate change than the 2013 report cycle? What are the key changes in understanding? And Olivia Rudgard of The Telegraph asks, are things worse than we thought? How do the conclusions in this report, both in terms of the scale and pace of human-caused climate change and the severity of its impacts, compare to what was found in previous reports in 2018 and 2014? I think that's for you, Valerie, but others might want to come in too.
Thank you very much. My understanding of the question is that it is first related to advances in science understanding. And I would like to stress a very important progress in understanding. The way we describe the climate response to greenhouse gas emissions is associated with an important measure, which is called climate sensitivity. Basically, climate sensitivity describes how the climate responds in terms of warming when you double the concentration of CO2 in the atmosphere. And scientists have been working on this issue since the late 1970s. And the range associated with the response of the climate system was about the same since the 1970s. But recently, thanks to important scientific advances, especially the understanding of feedbacks and especially crowd feedbacks, the range of climate sensitivity has been reduced. Therefore, we had a much more accurate understanding of the response of the global climate to emissions. And this is a major advance that is reflected in this report. It is one of the many examples, in fact, of scientific progress. You can find in our technical summary a 2-page summary of the major scientific advances compared to past IPCC reports. And regarding the second part of the question, we've known for a long time that with more emissions, climate would continue to change. And this report confirms with more robust findings that, for instance, a higher rate of greenhouse gas emissions leads to a higher rate of warming, and that this leads to an increase in the intensity and frequency of extremes. I would like to flag that on these aspects, we have a much clearer picture of the regional consequences that in fact scale with the level of global warming. And this is clearly reflected in our interactive atlas, which brings together information from global climate models that have advanced with higher resolution, and also regional climate models that are important to provide finer information at regional scales. And this is also a major advance.
Jonathan, can I add?
Yes, please, Penal.
Yeah, I think, we also have several aspects very important. One is, say, we assessed, we find that recent climate changes are now widespread, rapid, and intensifying. Even some of the changes we see today are unprecedented in thousands of years. I think that's very strong. Another is about human contribution, which says it is unequivocal that human influence has warmed the atmosphere, land, and the ocean. That means something like the human activity is influence not only temperature, but the whole climate system. And when we put all the literature and so many authors together, then we see the whole picture for the Earth system, the climate system, and that is quite strong. I think much stronger than AR5, which we said something like the attribution, more than half of the warming attributed to the human causes. I think that's another advances. And also we see climate change is already affecting all the regions on Earth in multiple ways. I think that's also something like influence everybody. We live in the Earth, and also they report clearly state that it is possible to limit future warming within a few decades. So that's my addition. Thank you.
Thank you, Panmal. Fatima?
Yeah, one thing I would like to highlight also is furthermore to the regional information, more regional information we have in this report. We have also focused on the climate services, which is an important aspect that is able to help and inform for decision making and adaptation at several time scales. So the climate services are very important aspects. They are able to, as I have said, to help for adaptation, for risk reduction, and even for evaluating the effect of mitigation on extremes and on weather and climate extremes. And I think this is an important aspect in this report. Thank you.
Thank you, Fatima. Carolina?
Thank you. I would like also to describe a short, important contribution that I think this report has, that is the quantification of the projected changes in extremes, for example. One of the conclusions, the projected changes in extremes are larger in frequency and intensity, but it also provides quantitative information about how the frequency and intensity change, let's say for a 10-year event of hot temperature extreme that in the pre-industrial period occur once in 10 years, the projection shows that will likely occur, for example, 5 and even 6 times more in the 2-degree world. And another important example for decision making, heavy precipitation events over land, like those that occurred 10 years with a recurrency of 10 years, now in a 2-degree future global warming level, will likely occur almost 2 times more frequent. Thank you.
Thank you, Carolina. Okay, one from Marie-Noëlle Bertrand. This 6th report is easier to read and understand than the preceding ones, more pedagogic, concrete, and regionally illustrated. Is this for people to understand it better or for the politicians to finally understand? Valerie, yes.
For this report, we have been extremely careful to explain the outcome of advances of complex climate science in the clearest possible way. And therefore, it is reflected not just in the entire report, which has frequently asked questions that are explained in plain language, but also in the summary for policymakers. And you can note that the main headline statements, our key scientific findings, are expressed in plain language so that they are accessible to everyone. We also worked hard to make sure that figures could be intuitively understood, thanks to work from specialists of figure design, as well as the authors of the report. And what we really would like is that this whole report helps enhance climate literacy worldwide, is used in teaching worldwide for teenagers, for students, so that they can learn the latest, best available knowledge. And we also would like this report to help any decision maker, also engineers involved in all sectors, to build on this latest science so that they can use it and develop responses as quickly as possible. Thank you.
Thank you, Valerie. Petteri?
Yes, I could complement that the fact why climate science is now taken more seriously by decision makers, businesses and finance sector is based on the science communication, which has been taking place since '88, the first report. Besides that, we have started seeing the impacts of climate change, and it's already visible. It was more theoretical in the '80s. The impacts were not so visible, but now they are, and that's why we are in a much better position when it comes to mitigation. The problem is understood. The only question is how quickly we are able to react, and luckily we have now better technical means and also financial means to be successful in mitigation, but we are not yet there.
Thank you, Petteri. Greg?
Yeah, thank you. I wanted to just add to what Valerie said in terms of the way that this report attempts to communicate to different audiences. So the report is structured with kind of three levels of communication. There's the summary for policymakers, which is aimed at a very high level audience, policymakers, decision makers, the general public. Then we have the technical summary, which is about 60 pages or so, that is aimed at a more specialist audience, but not the scientific community per se. And then we have the underlying chapters, which are each much longer and cover all of the subjects in much more detail. So for specialists or for people looking for information on a particular topic where they can get much more detail, the underlying chapters provide that. So depending on the kind of information you want, the level of expertise that different readers have, the report aims to provide that kind of information to all. And then it's supplemented by this interactive atlas that Pam Mao described early on in the presentation, that allows users to not just read the report, but really look at the data in different ways that are relevant to them. And I think that's really an innovation for this report.
Thank you, Greg. Edwin?
Yes, thank you for my time. I think the most absolute innovation in this report is the Atlas chapter. Atlas is very new, and then we don't present a picture or PDF paper, but we present people can animate or can make understanding better, so people can go through what happened in the climate change this year. But even this year, this is enough information, because there are a lot of information that people can see. This is very interactive atlas, interactive. We believe that this kind of experience in the atlas can develop further in the future IPCC report that can be in the new technology in the future. That is the most advanced innovation in this report. I think the second one is like Palmo mentioned and Valerie in the presentation, that 1/3 of the report is dedicated to the regional issue. This is exactly what the government wants. This is what we designed at the beginning, the whole chapter, and 1/3 of the chapter, 4 out of 12 chapter will be dealing with the regional issue. This is another innovation that is much more, and then we didn't have this kind of too much information for regional issue in the past. For the regional issue in this report, we compare to the IR5. Thank you very much.
Thank you, Edwin. Now from Thomas Hebsgaard of Zetland in Denmark. Media coverage can sometimes give the impression we would need to stay within 1.5 degrees or face climate catastrophe. So how should one think about the possibility of crossing that threshold? How should we think about continued efforts to stop further warming, even if we pass 1.5 degrees? I think Valerie first, but others maybe.
If you look at the evidence and the scientific information provided in this report, what is very clear is that many changes increase with any additional fraction of warming. So if you think of a 1.5 warmer world, our report shows that we need to be prepared for going into that level of warming in the coming decades. But we can avoid further levels of warming by acting on greenhouse gas emissions, and that's also a very important message from the report. When you look at regional information, when you look at how the climate system operates, there's no a single line, you know, where before that you avoid change and after that you have a very fast change. What we show in this report is that with any increment of further warming, you have further trends in temperature, precipitation in every region, further melt of glaciers, of Arctic sea ice, further increase in the frequency and intensity of extreme events. And this is the information we provide to decision makers so that they carefully consider the choices that they would like to make regarding climate change.
Thank you. Jan, please.
Yes, let me also point to the separate chapter we have in this report on short-lived climate forces. And these chapters address pollutants, aerosols, together with climate or greenhouse gases. And that gives a holistic view on the two issues, climate change and air quality. So that is, I would say, something new in this report. And we hope that it can be of use for the policymakers to see these issues together. Thank you.
Thanks, Jan. Okay, from Sonia Sanchez of Ara newspaper in Barcelona. Extreme events that now happen once every 10 years or every 50 years will be more frequent. Is it possible to put the recent floods in Germany in one of these two categories, and the heat wave in Eastern Mediterranean that's causing fires? Is it one of these events? How much more frequently will they happen?
Jonathan?
Yes, Panna.
I can take first say in our report we clearly stated that human-induced climate change is already affecting many extreme weather and climate events. So in every regions across the world, evidence are observed, that change seen, such as heat waves, heavy precipitation, drought. It's clear, climate change and human influence influence the climate system, and also influence the occurrence of the extreme events. However, for recent events, we have not assessed, because IPCC assessment is based on literature, and our cutoff data is January the 31st for the published paper. So in that aspect, the recent events, although they may have a clear connection to the climate change background, but we have not assessed. So we cannot very clearly say which individual event is how much contribute to the climate change. In our assessment report, we have another statement saying something, some recent hot extreme event, observed events, saying over the recent past, have seen extremely unlikely to occur without human influence on the climate system. So that means we also not exclude human influence on the extreme event we have today, but we haven't assessed the recent events yet. I think maybe in AR7 we can look at further and make it more clearly. Thank you.
Thank you, Pamela. Valerie?
Yes, thank you, Jonathan. The report is very clear that with further warming in the coming years, we expect to see new extremes that are unprecedented in magnitude, frequency, timing, or in regions that have never encountered those types of extremes. And I think an important aspect that is shared by all the authors of this report, all the scientists, is that, for decision-making worldwide, many people just look backwards. What was the extreme event of the last 30 years, of the last 100 years? But in a changing climate, that is not sufficient. It's really important to take into account these new types of extremes, these intensified extremes that are going to happen in the coming years or decades. And let me finish by one example. With gradual sea level rise, the extreme sea level events that occurred in the past just once per century will occur more and more frequently in the future. For most coastal places worldwide, those that occurred only once per century in the past are expected to occur once to twice per 10 years by mid-century. And the information we provide in this report is extremely important to take this information into account and to prepare for these events. Thank you.
Thank you, Valerie. Carolina?
Thank you. I would like to complement saying that while it is difficult to identify the exact causes of a particular extreme event, there is relatively new science of event attribution that is increasing and is able to quantify the role of climate change, altering the probability and magnitude of some types of weather and climate extremes. It's also important to mention that the effect of climate change on extremes is regionally different, as local factors also play an important role. So we thus can only give specific statements on events that has been assessed. But nevertheless, as it was mentioned before, there is strong evidence that characteristic of many individual extreme events have already changed because of human-driven changes to the climate system. Thank you.
Thank you, Carolina. Edwin?
Yes, I encourage you to read our SPM report. There is a terminology, we call it low likelihood, high impact event. That is our terminology, low likelihood, high impact event. This is part of the SPM. We dealing and discuss very much about this, and we give some example of what kind of event this is, like low likelihood and high impact event. Thank you very much.
Thank you, Edwin. Again, two related questions. One from Rhiannon Williams of Sky News. Is it your expectation that this report will make it easier for climate negotiators at COP26 to achieve consensus on ambitious targets and help nudge less ambitious countries into action? And Emma Farge of Reuters asks, is this year's COP26 the last chance to save us from warming? And what is the main message you hope policymakers attending will take from your report? Valerie first.
Thank you very much. I just would like to stress that this report has been approved by delegates from all governments. It is thus a common reference body reflecting the best state of knowledge. It is available 3 months before COP26 to be considered by decision makers. I hope that the report helps everyone understand climate science, where we are, where we can go, and the scientists who have prepared the report will be available, and they have amazing skills, knowledge. They are from all regions of the world, and I would like to invite them to be considered as the best ambassadors for the report, to exchange with regional, national policymakers, so that this knowledge is shared and is used. And the scientists who have prepared the report will be also available to present it at COP26.
Yeah, thank you, Valerie. Well, we still have dozens of questions. Oh, sorry, Inga wanted to come in there, sorry.
Merely to say that, let me turn on my camera here. Merely to say that therefore, based on the science and based on the data that is now available, it behooves every political figure and every decision maker, be it in the company, be it in local government, in city government, or indeed in national government, to look at their climate actions, to look at their emissions reductions, to assess how they can be a contributor and to report that into the conversations that is going to be happening at COP26 for governments, obviously through the NDCs, but for others, including companies, to set up a science-based targets against which they can measure their own performance and to ensure that business as usual does not become the continuation. So COP26 is very critical. Obviously, the scientist does not tell the politicians what to do, but they provide the very basis for people to have an understanding. And I would encourage that all recall that as citizens, we have a role too in requesting and ensuring that our governments are aware of that science. Let me stop here. Thank you.
Thank you, Inga. Fatima, please.
Yeah, thank you. And on the messages from the reports, I would like to recall one of the most important results is that with every additional increment of global warming, changes in extremes continue to become larger. And with more, to become larger, and this may be linked to both adaptation and mitigation requests. Thank you.
Thank you, Fatima. Well, we've only got a couple of minutes to go, but maybe we can squeeze in one or two more questions. So from Seth Borenstein of the AP, which of the 5 emission scenarios would you say the path humanity is now on? And is it a notable accomplishment that for the first time, humanity is not on the worst case 8.5 scenario? Someone wanted to come in on that last question. So do you want to do that first? Wei Sung, would you like to come in on the last question or this one?
Before you close the meeting, please give me the floor.
Yeah, sure. So the question from Seth Borenstein of AP, which of the 5 emission scenarios would you say we are now on? And is it a great accomplishment for the first time we're not on the worst 8.5 scenario? Valerie?
So in this report, we report the assessed response of global temperature and sea level in a consistent way with our assessment of climate sensitivity to 5 illustrative scenarios. It is not the mandate of physical climate scientists to assess the plausibility or the feasibility of scenarios per se. I can still flag that the high and very high emission scenarios are in the absence of additional climate policies. I can also flag that in the 1.5 special report in 2018, it was shown that the pledges from governments in 2015 would lead to global greenhouse gas emissions stagnating at a level close to today until 2030, which would more look like the illustrative intermediate scenario that we are using. And that scenario leads to reach and surpass 2 degrees of global warming by 2050. The next IPCC reports that are scheduled for the beginning of next year will provide much more information on mitigation pathways as well as on adaptation responses that are extremely important to inform decision-making and action.
Thank you, Valerie. And before we close, I'll give the word to Wei Sung, please.
Thank you, Jonathan. I believe some of our audiences outside in this room may wonder why the IPCC does not comment on the specific policies of our member government. And you probably have seen the other international organizations such as IEA or IAEA or IMF do such things. But we don't do such things. We are policy neutral because IPCC is a multilateral assessment body. So we are not advocating or negating any specific policy of our member government. I hope there is no misunderstanding in our position. Thank you very much.
Thank you very much for that reminder, Hui-Sun. It was very useful. Well, we've reached the end of our time, and sorry if we didn't get to all your questions today. There were many more there, but there'll be plenty of other opportunities in the coming weeks and months when we present the report, including at COP26, whether we're doing that virtually or in person or in a hybrid. And we'll be working together with the WMO and the UK Met Office in a joint pavilion there, where we'll be able to discuss this report in detail, as well as at other events at the COP. So, and as Valerie just mentioned, we have the IPCC Working Group 2 and 3 reports coming out in February and March next year. So thank you, and see you again soon. That ends this press conference.